First of all, thank all of you. I'll do it more formally when I do this, but I want to thank you all for being here. It's a very, very important meeting that we have today. I'm pleased to focus our conversation today on nuclear technology and how we can maintain and expand the use of nuclear energy both domestically and abroad. And I want to thank our witnesses who will provide us with a vision of our nuclear energy future. A lot happened in the last year on the nuclear front. First and foremost, we passed the Energy Act with the Advanced Reactor Demonstration Program, which was spearheaded by Senator Murkowski. We also were successful in lifting the Development Finance Corporation's ban on civil nuclear financing, allowing the U.S. to offer more competitive deals to the international community. Two of our witnesses, TerraPower and X-Energy, were selected as winners of the Department of Energy Advanced Reactor Demonstration Program, and congratulations. And $75 million was appropriated to initiate a uranium reserve, while we also authorized the Russian suspension agreement to prevent manipulation of our energy markets. With those accomplishments behind us, we still have a lot of work ahead of us. The public remains cautious about nuclear. Congress must pass legislation that allows states to have buy-in when it comes to the nuclear repository site selection and construction. And we must ensure that the National Nuclear Security Administration has the proper resources to operate their non-proliferation and safeguards program in coordination with the International Atomic Energy Agency. I look forward to working with members of this committee to accomplish these objectives. But today I want to focus on our efforts to build advanced reactors. The Department of Energy and our national laboratories play a central role in leading this effort in concert with private advanced nuclear energy companies. This public-private relationship is incredibly important, especially in delivering financing to commercialize these reactors. Already, private investments have surpassed $1.3 billion. This is largely because of their enormous market potential for electricity, process heat for manufacturing, electrolysis for hydrogen production, and desalinization. We include important provisions with the Energy Act directing the continued research of how to develop hybrid and integrated energy systems to operate seamlessly together. Idaho National Lab, the National Renewable Energy Lab, and NETO in Morgantown, West Virginia are leaders in this effort. Nuclear power provides about 10% of the world's electricity and prevents approximately 2 gigatons of carbon from reaching our atmosphere every year. But about 789 million people around the world still live without any electricity. Nuclear energy can be part of delivering that electricity to lift people out of poverty and provide the opportunities that many have become accustomed to. The Tennessee Valley Authority was created to do that very thing during the Great Depression. This is a model that can inform our efforts both domestically and abroad. Russia and China have made a strategic effort to supplant our nuclear leadership over recent years, and we must push back. With the necessary policy and funding, we can maintain our nuclear supply chain, create high-paying manufacturing jobs, and reassert U.S. leaderships. We also need to discuss the role of our existing fleet, where we are seeing more closures. This year alone, 5 reactors at 3 locations with 5.1 gigawatt capacity are slated to close. The International Energy Agency found that across the advanced economies, if countries continue to allow nuclear reactors to be prematurely shut down, it will be $80 billion a year or more costly to meet emission goals. That's $80 billion more each year. Lifetime extensions are cheaper than new builds and are generally cost competitive with other generation technologies. We cannot afford to let this carbon-free energy resource fade out. So with that, I'll turn it over to my ranking member, Senator Brasso, for his opening statement.
Well, thank you very much, Mr. Chairman. Thanks for holding this very important hearing today. Now more than ever, Washington must advance policies to preserve and to expand the use of nuclear energy. Nuclear technology is fundamental to meeting our energy, our environmental, and our national security goals. Nuclear power is our nation's largest source of carbon-free energy. In terms, it's critical to reliable electricity, resilient electricity, affordable electric service, all of them. During last month's cold snap, nuclear power plants, by one key metric, outperformed all other energy sources. For the last 75 years, America's nuclear energy industry has been the world's leader in safety as well as performance. We need to ensure our leadership endures. As we speak, America's adversaries, Russia and China, seek to undermine our nuclear industry. Russia and its satellites have intentionally dumped uranium into our market. They undercut American uranium producers and processors. They drive our companies out of business. America's uranium production is so low, it is now at a level not seen since the 1940s. We're on the brink of finding ourselves completely reliant on foreign uranium to power our nuclear power plants. This is unacceptable. The Biden administration must take decisive action to prevent this from happening. Last year, Congress approved and appropriated $75 million to establish a national uranium reserve. This year, Secretary Granholm should complete the establishment of the reserve, begin a purchasing program, and buy American-produced uranium. We must maintain our ability to produce and process our own uranium. In addition to losing our uranium producers, we are also losing our nuclear reactors. Currently have 94 operating nuclear reactors. These reactors provide 20% of our nation's electricity. Since 2013, 11 reactors have shut down. Even more are scheduled to retire by 2025, including 5 this year. Many of these plants could safely remain online for decades. While the reasons for these closures may be complex, too often the result is that carbon emissions go up nationally and electric reliability goes down. That's why Senator Whitehouse and Crapo and Booker and I have introduced the American Nuclear Infrastructure Act. We did that last Congress. Among other things, the bill would keep reactors online at the risk, those at risk of closing permanently or closing prematurely. Last December, the Environment and Public Works Committee reported this bill with broad bipartisan support. Innovation will also be key to reestablishing America's leadership in nuclear energy. 2 years ago, President Trump signed into law the Nuclear Energy Innovation and Modernization Act. It's a bill I introduced along with Chairman Manchin and Senator Risch and others. This bill established a network for the Nuclear Regulatory Commission to approve advanced nuclear reactor designs. Over the next decade, we expect advanced nuclear technologies to be deployed. New reactors will be safer, smaller, and more efficient. Advanced nuclear reactors will generate less nuclear waste. Some may even run on previously used nuclear fuel. Advanced nuclear technologies will enable new market opportunities beyond the electricity sector. The heat from advanced nuclear reactors can drive a variety of industrial processes. It can improve the efficiency of chemical and hydrogen production. This heat can clean up wastewater and make salt water from our oceans usable. Advanced nuclear reactors will also improve access to materials used to diagnose and to treat diseases. They will even power missions to space. The world is looking to nuclear power to meet its energy and environmental goals. We must ensure American technologies are leading in this global expansion of nuclear energy. American leadership in this sector is critical. It's critical to ensure nuclear energy is used safely for our peaceful purposes. Today, we will hear directly from the industry executives working to maintain our historic leadership in nuclear energy. I look forward to the testimony. Thank you, Mr. Chairman.
Thank you, Senator Brasso. And now let me welcome our highly qualified panel of witnesses for their opening statements, starting with Mr. Jeffrey Liash, who is President and CEO of Tennessee Valley Authority. Mr. Liash, thank you for being here.
Thank you, Chairman Manchin, Ranking Member Barrasso, and members of the committee. And thank you for the opportunity to appear today and to represent one of the nation's largest and most innovative utilities and a corporate agency of the federal government, the Tennessee Valley Authority. My career began in the energy industry 40 years ago, and it included service at the U.S. Nuclear Regulatory Commission and in both public and investor-owned utilities. I spent a significant portion of my career building, maintaining, and operating nuclear facilities. And I believe that nuclear energy plays an important role in our nation's current and future energy supply, and I appreciate the committee's interest in this important resource. TVA has a clear mission to serve the nation and the people of the Tennessee Valley. Our employees deliver on this mission by focusing on 3 mission-related areas. First, energy, low cost and reliable. Second, environmental stewardship, protecting and managing natural resources. And 3, economic development, attracting and retaining jobs and capital investment. It's as powerful a mission as I've seen in my career. And TVA funds this mission entirely from energy sales, no federal appropriations. As I look to the future, the alignment and interdependency of these 3 mission elements only grows stronger. Energy, environment, and the economy must move together and forward in balanced lockstep. A core TVA strength is our diverse and clean generating portfolio, one of the most diverse in the industry, including hydroelectric power, renewable energy, natural gas, and a lessening contribution from coal, and the nation's third largest nuclear fleet. Our power system is one of the most reliable in the industry. We serve many rural communities over a 7-state region who are economically disadvantaged, so the price of electricity in our region matters. We've kept energy costs low and stable for most of the last decade, and we intend to keep them flat. Our system's also one of the nation's cleanest, with 60% coming from carbon-free sources last year. The aggregate of this supports quality economic growth in a region that is home to 10 million people. And in the past 5 years, TVA's helped deliver 341,000 jobs and over $45 billion in capital investment to the region. Consistent with our environmental stewardship mission, we're a leader in carbon reduction, having already lowered our greenhouse gas emissions by 60% when compared to the 2005 benchmark. We accomplished this by incorporating renewable energy assets, replacing aging plants with new high-efficiency natural gas, and, importantly, expanding our nuclear program. We're committed to continuing this effort by executing our plan to reduce emissions 70% by 2030 and building a path using existing technology, including nuclear power, to an 80% reduction. Of course, our aspiration is to achieve net zero carbon emissions and to support broader national efforts to decarbonize the economy. If we continue to lower greenhouse gas emissions without sacrificing cost and reliability, efficient electrification could be a key to decarbonizing other sectors of the economy. We already see this in the rapid development of electric transportation technology. Electricity as a percentage of final energy has risen from 3% in 1950 to 21% in 2020, and studies project that this could be 40% by 2050. As electricity grows, so will customers' need for affordability and reliability, and our challenge is to lower existing fleet carbon emissions while adding reliable and affordable low-carbon resources to support electrification. Maintaining balance between price, reliability, electric generation sector CO2, and electrification will help deliver a sustainable economic advantage. Now, this will require investment in technologies such as energy storage, carbon capture, low-carbon fuels, and advanced nuclear design. Currently, 42% of TVA's total power supply comes from nuclear, and I believe that nuclear energy will play a critical role in our collective path to a net zero carbon future. This large-scale energy source delivers reliability, cost-effectiveness, carbon-free energy, and its dispatchability, fuel stability and security, diversity, and its regional positive economic impact is unmatched, and frankly, it's unrecognized in the organized market. Optimizing and extending the operating lifetime of our nuclear fleet has got to be a primary focus. We've already extended the lives from 40 to 60 years, and we will shortly extend to 80, perhaps 100. But while extending these lives is critical, it's not sufficient. TVA is actively engaged in developing new nuclear technology for tomorrow. Enabling new nuclear here will take innovation and creativity, but it also takes old school discipline and hard work. The momentum for new reactors is growing, and that momentum can lead us to a diverse portfolio of advanced reactors to meet new needs. At TVA, we received an early site permit from the NRC for our Clinch River site. We're currently executing the environmental assessment process as the next step to establish this as a future option. And our team is engaged with technology developers, including those that are here today, to understand cost and risk associated with various reactor designs. When we begin site-specific engineering, it will be after an extensive and careful series of preparations. Our current schedule is to have a small modular reactor, perhaps in service at Clinch River by 2032. In summary, TVA has long been a leader in technology innovation. Nearly 90 years after our founding, pursuing new ideas and innovative solutions is an important part of everything we do. We believe nuclear technology plays a critical role in maintaining the necessary balance between price, reliability, generation sector CO2 reduction, and efficient electrification that will help deliver on our environmental goals and build sustainable economic advantage for the country. Thank you, and I look forward to answering your questions.
Thank you, Mr. Lash. Next, we have Mr. Levack, President and CEO of TerraPower. Mr. Levack.
Thank you, Chairman Manchin, Ranking Member Barrasso, and members of the committee. My name is Chris Levack, and I'm the Chief Executive Officer of TerraPower. TerraPower was founded by Bill Gates and Nathan Myhrvold in 2006 to solve the dual challenges of the growing global demand for energy and the rising threat of climate change. Our mission is to improve nuclear energy delivery using 21st century technologies to increase safety, reduce costs, reduce the risks of weapons proliferation, minimize waste, and more efficiently use fuel. America is well positioned to lead on advanced nuclear. TerraPower's goal is to provide a commercial product that provides reliable, zero carbon, cost-effective energy solutions. This is a critical period for nuclear power. Nuclear provides a majority of the clean energy in the United States and is now America's second largest single source of electricity. But more nuclear plants are slated for closure than are currently being built. As the IPCC has noted, meeting aggressive climate goals requires expanding global nuclear capacity in the coming decades. This presents an opportunity for our industry both here and, importantly, globally, to meet this growing demand. Thankfully, the committee recognizes it is time to demonstrate and deploy American advanced nuclear technology. Last year, TerraPower was grateful to win a competitive award for the Advanced Reactor Demonstration Program, a program authorized by this committee, to demonstrate our Natrium technology. Natrium is designed to meet the energy needs of the 21st century electrical grid, which is facing growing resiliency challenges as fossil plants are retired and clean but intermittent sources like wind and solar are deployed in mass. Natrium not only generates clean energy at 345 megawatts rated electrical output, it can also store heat from our reactor in a molten salt storage system, allowing it to deliver 500 megawatts of power for 5.5 hours. Such storage capability is 4 times greater than the largest lithium battery storage system in the world. It allows Natrium to work well with renewables like wind and solar. This is a benefit because as more utilities plan to dramatically reduce or even eliminate emissions and pollution from their power system, they need firm dispatchable power and hours-long storage capability that batteries cannot economically provide. We are confident that Natrium's cost and safety profiles will make it an attractive option for utilities around the world. Natrium's novel architecture provides significant improvements in safety. Instead of water, Natrium uses sodium as our coolant, which has a boiling point of 882 degrees Celsius. Unlike conventional reactors, Natrium operates at atmospheric pressure, and its operating temperature is hundreds of degrees below the boiling point of the coolant. This greatly reduces the likelihood, and importantly, the severity of any accident. Our design relies on natural forces, like convection, to cool the reactor after an unexpected shutdown. Because inherent safety is built into the reactor design, we are able to reduce the number of man-made systems needed to ensure safety, which results in cost savings. In addition, the Natrium architecture separates the energy storage and electricity production systems from the nuclear island, allowing us to further decrease costs. The committee has also recognized the role the federal government can play in developing advanced nuclear technology, like it has for civil nuclear advances over the past half-century. Companies like TerraPower and X-Energy have spent many years and hundreds of millions of dollars to develop our technologies. The ARDP, which establishes a 50-50 cost share program to build the first commercial scale units to demonstrate the technology, comes at a critical moment. If Congress continues to fully fund the ARDP, we will have multiple advanced reactors fully demonstrated and commercially available in the late 2020s. Reactors that will help establish will help the United States decarbonize, create good, high-paying jobs, and allow our country to reestablish leadership, strengthening our nation's security. We urge Congress to continue funding the ARDP at the levels required to demonstrate both of these reactors under the timeframe Congress mandated. TerraPower appreciates the committee's bipartisan support for nuclear. You recognize that the country that owns the advanced nuclear transition will be a leader in the global nuclear market. As countries around the world turn to nuclear energy for reliable, clean, and abundant energy, we will have American technology options to offer them. I look forward to taking your questions.
Thank you, Mr. Leback. And next we have Mr. Scott Melby, President of the Uranium Producers of America. Mr. Melby.
Thank you, Chairman Manchin and Ranking Member Barrasso. It is an honor to testify before the Senate Energy and Natural Resources Committee. I'm a second-generation American uranium miner and currently president of the Uranium Producers of America and executive vice president of Uranium Energy Corp. With operations in Texas and Wyoming. I have 36 years of experience in every facet of the international nuclear fuel cycle, from the production and global marketing of uranium to its use as clean energy fuel in the Palo Verde Nuclear Station near Phoenix, Arizona. This is an exciting time for nuclear, which is already providing electricity in 1 in 5 American homes and over half of our nation's carbon-free power. Nuclear power can work hand in hand with other green technologies like wind and solar to help advance the American clean energy revolution. But the United States must establish its global nuclear leadership, including a robust nuclear fuel cycle that has been eroded by Russia, China, and state-owned entities in recent years. America is dangerously close to losing our uranium fuel industrial base. We lack a domestic enrichment capacity free of control by foreign powers. The sole U.S. conversion facility in Illinois has been idle since 2017 and will restart operations in 2023. We are nearly completely dependent on foreign uranium imports, state-owned entities in Russia, Kazakhstan, and Uzbekistan who are supplying almost half the fuel used by America's reactor fleet. And Chinese state-owned entities are capturing large portions of global uranium mining capacity, taking supply out of the free market and putting it under Beijing's control. Uranium is also required for naval propulsion and nuclear deterrence, the pure essence of what it means to be a critical mineral. The 93 small modular reactors in our fleet of 82 aircraft carriers and submarines have defended our interests safely and reliably since the 1950s. These reactors must rely on U.S. origin uranium, which is unobligated to the controls of foreign nations, and we need to retain our ability to independently refuel them. TVA's tritium production and Department of Defense microreactors have similar domestic uranium requirements. Absent a renewed commitment to America's nuclear fuel cycle, we are jeopardizing our defense capabilities and our clean energy goals. Russia and China fully leverage energy dominance to their geopolitical advantage. They are playing a long game in a way America is not, using their nuclear energy clout to strengthen geopolitical ties with energy-starved countries around the world. America is also risking its seat at the global non-proliferation table. The similarities to our rare earth mineral dependence on China are startling, but it doesn't have to be this way, and it isn't too late. We have over 1 billion pounds of uranium in known and likely deposits in the United States. With 21st century conventional mining practices and environmentally friendly in-situ uranium recovery technology, the modern uranium mining industry is very different than was the case back in the 1950s. We are highly regulated and embrace, for many reasons, the world's highest health, safety, and environmental protection standards. And we are cost competitive globally, but for the price undercutting tactics of state-owned companies. With swift action to implement the Strategic Uranium Reserve, the Department of Energy can take advantage of the licensed infrastructure and human resources we still have on standby. Congress recently appropriated $75 million for the Uranium Reserve on a bipartisan basis and with the support of nuclear utilities. It is crucial the department move quickly to begin purchasing uranium this year. This will preserve the industrial base, guard against global supply disruptions, and create a source of U.S. origin uranium for defense needs. We urge Congress to grant the full funding recommended over the next 10 years, by the Interagency Nuclear Fuel Working Group led by Department of Energy. $150 million a year is a modest investment considering it will preserve the nuclear fuel cycle in the U.S. instead of ceding it to China, Russia, and their allies. In closing, I applaud this committee for exploring ways to advance America's nuclear leadership and capabilities in support of clean energy goals, national security, and our global competitive presence. I look forward to taking any questions that you may have.
Thank you, Mr. Melby. And next we have Ms. Amy Roma, funding member of the Atlantic Council's Nuclear Energy and National Security Coalition and a partner at the law firm Hogan Lovells. Ms. Roma?
Good morning. My name is Amy Roma, and I'm a member of the Atlantic Council's Nuclear Energy and National Security Coalition and a lawyer at Hogan Lovells. Thank you for the opportunity to testify today. Commercial nuclear power has always served as an important tool to achieve U.S. national security objectives and U.S. economic interest. In 1954, at the dawn of nuclear power, President Eisenhower delivered his famous Atoms for Peace speech, offering to share U.S. nuclear energy technology with other nations who committed not to develop nuclear weapons. This program resulted in three important economic and national security objectives. First, it prevented the spread of nuclear weapons. Second, it made the United States the leader in nuclear power, ensuring the U.S. maintained dominance in nuclear safety, security, innovation, and nuclear trade. And third, it ensured the U.S. benefited from the geopolitical relationship that goes with such significant assistance with a foreign country's power supply. President Eisenhower's historic move has paid dividends for decades, and the U.S. was long positioned as the global leader in commercial nuclear power. And remarkably, the same arguments used to support nuclear trade after World War II are still just as relevant today. That is, that the United States should lead in nuclear trade because if we do not, another country will. And while the U.S. still has the largest nuclear fleet and best run plants in the world, we have seen our international role as a global leader in nuclear power sharply decline, replaced largely by Russia, with China close behind. Russia and China have identified building nuclear power plants and nuclear trade as national priorities, promoted by the highest level of government and backed by state financing in state-owned enterprises. And their focus has paid off. Nuclear power plants are being built all around the world, but Russia is building them. Russia uses nuclear exports as a tool to exert foreign influence and reap significant economic gains, with a claimed $133 billion in orders for foreign reactors. Nuclear energy is also a component of China's Belt and Road Initiative, with China estimating it could have $145 billion in orders for foreign reactors and create 5 million Chinese jobs. The U.S. nuclear power industry, competing against state governments for new projects, has quickly been sidelined on the foreign stage, with no new orders for nuclear reactors abroad. The global market opportunity is huge and growing, and the impact of the lack of U.S. leadership is wide felt. The current market for new nuclear is already in the hundreds of billions of dollars. If carbon mitigation measures are deployed, the global nuclear market would be in the trillions of dollars. Sitting by the wayside and letting Russia and China continue to capture this market hurts not only our country's economic interest, but it also undermines U.S. national security, technical innovation, and geopolitical interest. Russian energy policy in particular expressly recognizes the export of energy technologies as a geostrategic tool to promote Russian national security. As one example, Egypt and Russia recently finalized a $21 billion contract for the Russians to supply 4 reactors in Egypt. A few months later, Egypt and Russia announced a preliminary agreement to allow Russian military jets to use its airspace and bases. This agreement will give Russia its deepest presence in Egypt since 1973. While China appears to generally view nuclear power exports as an important economic opportunity, its expansion and developing new nuclear technologies also has defense implications. For example, China plans to build a number of floating nuclear reactors to provide power to the artificial islands that it is currently building in the South China Sea, a hotly contested area. These same weapons can support not only power for these islands, but also provide power for advanced weaponry. While the U.S. has ceded the current mantle, we have a chance to regain it when it comes to the next generation of advanced reactors, where we hold a significant innovation edge. In particular, The U.S. leads the world in the development of advanced fission reactors as well as the nation's fusion industry. These advanced technologies are diverse, but share common design features such as they are simple, scalable, and safe, and can be used for both power and non-power applications such as hydrogen production, water desalination, and process heat for industrial uses. U.S. innovation, when properly supported, can stand up to state-backed competitors. We saw this recently in the aerospace market. In 2013, Russia controlled about half of the launch industry. Due in large part to the success of SpaceX, shepherded by NASA's COTS program, Russia is now estimated to capture only 10% of the market. We came back with a 1-2 punch. First, the punch of U.S. innovation, and second, the punch of the U.S. government providing commercialization support. So we can emerge here as a global leader in nuclear power with U.S. government support. The opportunity is there, we have the innovation, and the stakes are worth it. Thank you, and I'm happy to answer any questions that you may have.
Thank you, Ms. Roma. And now we have Mr. Self, he's our final presenter, and he is CEO of X Energy. Mr. Self.
Chairman Manchin, Ranking Member Barrasso, and members of the committee, thank you again for the opportunity to provide testimony today on current developments in the U.S. nuclear energy sector. I respectfully request that my full written testimony be submitted for the record, and I will briefly summarize my remarks. My name, again, is Clay Sell, and I'm the Chief Executive of X Energy, a clean energy technology company founded by Dr. Cam Ghaffarian. We are developing Generation 4 high-temperature gas-cooled nuclear reactors, and we are also a manufacturer of special TRISO-X fuel used in our reactors and other advanced reactors emerging on the market. Our commercial plant has 4 80-megawatt electric modules and totals 320 megawatt electric. It's in an optimized configuration, sharing a single control center and other plant infrastructure. Our plant is intrinsically safe, benefits from a simplified and flexible design, and is economically attractive for a variety of electricity and process heat applications. This is the plant that we will build with our utility partner, Energy Northwest, as part of the Advanced Reactor Demonstration Program, authorized by this committee and signed into law last year. Our DOE award will deliver a project requiring approximately $2.5 billion in expenditures between now and 2027 to achieve 3 major scopes of work. We will complete the final design and licensing of the plant at the US NRC. We will license and construct the first phase of our commercial fuel plant in this program, and we will construct, fuel, and commission the commercial scale plant in Richland, Washington. I came back to the nuclear industry with X Energy 2 years ago, after 10 years in the oil and gas and renewable development business. I do have a passion for nuclear energy, and I've had it for 20 plus years. But that is not the reason I came back to nuclear energy. I came back because of the immensity of the business opportunity before us. With global energy demand increasing by 50% by 2050 and the need to dramatically reduce carbon emissions, the business opportunity for nuclear power is simply massive. And we at X Energy see a different future for nuclear power than what has gone on before. And we are creating it with the help of visionary leaders in the Congress and the Department of Energy. I believe the revitalization of the U.S. nuclear industry is a strategic imperative for our country. Now, as I testify along Mr. Levesque from TerraPower, they are the other U.S. company that was awarded a demonstration contract. I just want to make something, and TerraPower is a company is a respected competitor and a company that we hold in the highest regard. But they are not the real competition. The real competition, as you've heard in other testimony today, is state-owned Chinese and Russian companies. And today, those companies have replaced the United States as the dominant sellers of new nuclear power plants in the world. The Chinese and Russian enterprises know that nuclear power plant sales in foreign markets create 80 to 100-year relationships that become tightly woven into the fabric and destiny of a country's energy and critical industrial infrastructure. If the U.S. will not, or if the U.S. cannot compete in these export markets, the resulting global realignment of nuclear commerce will negatively impact our national security interests and our international influence for decades to come. In this geopolitical light, the Advanced Reactor Demonstration Program takes on even greater importance and value. I know that Congress recognizes this and sees the ARDP as a necessary and powerful tool that will reinvigorate our domestic and export industries, including uranium production and domestic enrichment capabilities, thereby allowing the U.S. to reclaim its position of global leadership and influence now. I would like to highlight 3 challenges that required continued vigilance. First, availability of sufficient quantities of high-assay, low-enriched uranium, known as HALEU, to fuel both the X-Energy and TerraPower reactors. We will need that beginning in 2024, and it remains a critical concern. The committee has provided strong leadership, but I have outlined additional policies in my written testimony that I respectfully urge the committee to pursue. Second, continued reform and evolution of the NRC licensing framework, appropriate to the reduced risks and improved safety cases of advanced reactors, will require continued vigilance. And finally, predictable and consistent appropriations to match the billions of dollars of private capital committed to these demonstrations will be essential to delivering the projects on schedule by 2027. I hope I've provided you some insight into the value of this program and the exciting market opportunities. At X-Energy, we're proud to join with the leadership of the committee to reclaim our global leadership position in this great American-born industry, to create thousands of new high-paying American jobs, to enhance our energy and national security, and to ensure the high standards for safety and security around the world. Thank you for the opportunity to testify. I look forward to your questions.
I want to thank all of you for expert presentations. We appreciate it very much. I'm going to start turning it over to Mr. Barrasso. I have to go to a quick meeting. I'll be right back. He'll start with the questioning, and we'll continue with questions.
Thank you, Mr. Chairman. Mr. Melby, could you please explain why it is so important that the United States maintain our ability to produce and process our own uranium?
Well, Senator Barrasso, uranium, as you know, is a critical mineral in every sense of the definition. Not only supplying 20% of our electricity in the United States, it is over half of our carbon-free energy. And the use in the nuclear navy and other defense programs cannot be understated, where we definitely have to have the domestic infrastructure available to support those programs. And it's also about nuclear leadership around the world as well, as we're going to be competitive against China and Russia in competing in markets for these advanced reactors, small modular reactors. We need to have the whole package, and fuel cycle is part of that. It's something our competitors, our government competitors are offering. We need to be competitive in that as well.
So last year, Congress appropriated $75 million to establish this strategic uranium reserve through the Department of Energy. Why is it so urgent that the department establish that reserve, begin to purchasing program, and buy American-produced uranium this year?
Well, Senator Barrasso, as you know, the uranium market conditions have really been crushed by, I would call it, predatory pricing by these state-owned entities. But we still have the infrastructure in place. We still have the companies and expertise hanging on to recover and grow and not just survive but thrive in the uranium industry. But we do need that support urgently. We've gone through quite a period of low uranium prices. But the promise of the uranium reserve has already resulted in significant serious measures being taken at a number of our member companies to advance their operations to be ready to supply into that uranium reserve very quickly.
Thank you. Mr. Levesque, I appreciate you joining us from the other side of the country, and I appreciate the work that you've been doing. In your testimony, you discuss how TerraPower's Natrium advanced nuclear reactor is safer to operate, produces lower volumes of waste, and is cheaper to build than conventional light water reactors. You also discuss how the Natrium reactor will power a molten salt energy storage system, which can store much more energy than a typical battery storage facility could do. Could you elaborate on the benefits of the Natrium reactor?
Yes, Senator, I'd be happy to. And I should begin by referencing the great safe operating record of light water reactors, that are operated by, TVA's fleet, for example, that Mr. Lyash discussed. I've in fact operated light water reactors earlier in my career as a submarine officer. So those reactors are very safe, and TerraPower totally agrees that light water reactors like the ones at TVA should have license extensions to 60, 80 years, possibly more. Beginning with that great safety record, there are in fact technologies that have been developed in the national labs for literally decades, and by companies like TerraPower and X Energy that are now ready for demonstration now. And to focus on TerraPower's Natrium technology, as I mentioned, Natrium is a sodium-cooled reactor. So where past reactor designs, the ones that have been demonstrated by the U.S. in the late 50s at the Shippingport station, past reactor designs are water-cooled, high-pressure systems. Natrium is a low-pressure system that operates hundreds of degrees centigrade from the boiling point of the coolant, which is sodium. That offers great safety benefits. Also, sodium naturally retains radioactive materials like iodine and cesium, so you don't have to worry about those radioisotopes getting out into the containment and into the environment. So it offers a order of magnitude lower accident and severity rate on an already improved or already great record in the light water reactors today. Also, the fact that it's a low pressure system is really important for reducing cost. Light water reactors today are high pressure systems that not only need very heavy components, but need heavy piping systems and heavy civil structures, heavy buildings and steel to support them. Well, if you start with a lower pressure system, your components can then be lighter, and your civil structures can then be lighter and cheaper as well. TerraPower also has a really novel architecture. Instead of boiling water with our reactor heat directly, the way reactors have done for over 50 years, we looked really closely at what's going on with the grids today, and the growing expansion of wind and solar, which is good for clean energy and good for decarbonization. But that's creating grid resiliency issues, energy storage needs. So with Natrium, what we're doing with the heat before we boil the water to run turbines the conventional way, we first store the heat in large molten salt storage tanks. The same technology that concentrated solar plants have today, because they have to deal with the sun going in and out, but their customer demand is there all the time. So what Natrium does on top of having these safety and cost benefits, it's really the first American nuclear reactor, first nuclear reactor anywhere that offers energy storage. And instead of being a baseload supply of electricity, as nuclear has been for 50 years, Natrium now provides a peaking capability that can ramp up and down as intermittent sources like wind and solar come and go.
Thanks so very much. Senator Cantwell.
Thank you, Mr. Chairman, and thank you to you and Senator Manchin for holding this important hearing. Obviously, the state of Washington has had a long history in nuclear power, and I think that continues today. We're here to talk about the impacts of the next generation of nuclear energy. And I would say that the workforce in the Tri-Cities is especially excited about that. They've had a long history there. Today, over 12,000 nuclear skilled scientists, engineers, and craft workers are working there in 100 different companies. So it certainly is a home to a lot. Columbia Basin and Washington State University campuses offer bachelor's, master's, and PhD in nuclear-related fields, and the region hosts a strong apprentice program. In fact, I'd like to enter, if I could, Mr. Chairman, into the record, a letter from Nick Bumpus, president of 16 affiliated unions of Central Washington, in support of DOE's Advanced Reactor Demonstration.
Without objection, so ordered.
Thank you. So obviously, and PNNL gets a lot of money, $400 million, I think, a year to do R&D in nuclear-related fields. So we're very excited overall about this next generation of clean power. So Mr. Sells and Levesque, you both testified to the benefits, particularly in comparison to light water reactors, but how integral is the federal support for the advanced nuclear energy technology as a continuation to meeting our goals? And how important is Washington State's Clean Energy Transformation Act, requiring sources be carbon-free by 2030 as a motivation to keep going? Also, I want to just, I should just mention, I would certainly appreciate Bill Gates and Nathan Myhrvold's efforts on TerraPower over a long period of time, and recognition that the company is there. And Mr. Sells, you and I just had a conversation about X-Energy's larger footprint in the Tri-Cities. So anyway, we're all good. So maybe just tell the rest of us about the state's initiative and the federal support and what we need to keep doing.
The first thing I will say is the federal support through the Advanced Reactor Demonstration Program is critical to seeing first-of-a-kind reactors built.
You mean commercialization?
Yeah, we are demonstrating a full-scale commercial plant, just like the plant that we will sell in Canada, that we hope to sell to TVA, that we hope to sell around the world. But the first plant is always the most challenging one to get built because all of the inherent risks associated with the first-of-a-kind plant. And so the federal support, which, the federal government in our case is putting $1.2 billion into the project, but the private sector is matching that with $1.2 billion. So it's a critical accelerator to investment. We wanted to be in Washington State for our first-of-a-kind project. We wanted to partner with Energy Northwest. We have great regard for their CEO, Brad Sawatsky, and the way he has dramatically improved the operations of their single nuclear reactor over the last 10 years. But the critical thing was the way the market has been shaped by the CETA law in Washington that was passed in 2019. That is the most transformative thing that has happened in nuclear energy markets in the United States because it has created the commercial framework for nuclear to succeed and to succeed wildly. And as Washington State phases out coal by 2027 and then natural gas by 2045, that's going to generate an 8 gigawatt gap of baseload emissions-free power that needs to be filled. And the opportunity to do that with nuclear power, to continue the great nuclear tradition in Washington State, to continue the great tradition of emissions-free generation, is something that we really look forward to doing in Washington State by 2027. And we anticipate that we'll break ground on the initial non-nuclear construction there by the middle of 2023.
Mr. Levesque, hard to top that, but you can try.
Yes, nice to see you again, Senator Cantwell, and thanks for all your support in Washington. Again, TerraPower is based in Bellevue, Washington, near Seattle. I completely agree with Mr. Sells' points on the kind of federal and state support that has really been positive in the last couple of years. I'll elaborate a little bit on the design of the Advanced Reactor Demonstration Program. It's really an excellent program for many reasons. I think the chief reason being the public and private cost share. These technologies that we're talking about, Generation 4, advanced nuclear technologies, they've been worked on in the national lab for up to 20 years. TerraPower is a 14-year-old company. We've been working on the Natrium design with private investment, funding work at national labs. But all that work is really for naught if we don't demonstrate the reactor. These will just be PowerPoints and technical papers. If we don't demonstrate the new technology, the way the U.S. did in the late 1950s, we demonstrated light water technology at the shipping port station in Pennsylvania, which led to 400 reactors around the world based on U.S. origin technology. If we don't demonstrate now, all of this technology investment that's been made by companies like TerraPower, X-Energy, and government investment at the national labs, it will be for naught. So ARDP is coming at the perfect time. You heard about the growing demand for electricity that's going to come with electrification of transportation and the industrial sectors, while at the same time we're shutting off coal. That's going to create a great demand for clean energy generation, like TerraPower's Natrium reactor. So the ARDP is really well designed, in that it requires significant private cost share. If we think about the investment that TerraPower will be making during the construction of the demonstration reactor, that investment, along with X-Energy's, will certainly be the largest private investments in nuclear energy in history. And the ARDP enabled this.
Thank you.
Now, yes.
Thank you. I'm sorry, I'm way over my time, but I appreciate your refined points. I am going to ask, Mr. Chairman, record question that is just that we can get the witness on, because it begs the question, if what Washington did in setting this market, or in encouraging this kind of development, obviously again in coordination with the federal government, what else could we be doing on setting a more predictable price that would signal to the rest of the United States and otherwise stop reactors from being shut down? So I do think it's an interesting question. We'll get the witnesses on that. But thank you, Mr. Chairman, for this important hearing.
Thank you very much. Senator Cortez Masto.
I am here. Hang on. There we go. Thank you. Thank you so much. I appreciate the hearing today. Let me start with, let me just say to the chairman very quickly, because as everybody knows, I'm from Nevada. I'm for consent-based siting for nuclear waste. I think it's something that needs to be done. I think particularly as we look to nuclear power, this is an issue we have to address as a country. And I think every state should be treated equally. Let me just thank the chairman for his opening remarks. I also want to just recognize again that S541, the Nuclear Waste Informed Consent Act that Senator Rosen and I introduced, I think is so important. I hope that my colleagues, we can all, along with the industry, address this issue, but treat every state equally. Every state should be a part of this solution and be treated equally. So I appreciate the opportunity just to make that statement. Mr. Melby, let me start with you. In your written testimony, you raised some concerns about our domestic workforce, noting that the nuclear industry, and I quote, requires trained, experienced, and skilled engineers, geologists, scientists, technicians, and operators. I am curious to hear more about the current overall status of our workforce and whether or not the panel thinks that the U.S. has enough nuclear engineering professionals to fully ramp up development and deployment of advanced nuclear technologies.
Well, thank you, Senator. And I can speak from the experience of our company, Uranium Energy Corp. As I sit around our operational staff meetings and I look around at the folks around the table, a lot of them are in their 60s and even into their 70s and providing consulting even after they leave our company. We've tried as a company to really provide mentoring for younger people and professionals, and we've been able to do that, but it's difficult in a low uranium price environment to have that kind of bench strength. But I'm totally confident that schools like Texas A&M, Colorado School of Mines, University of Wyoming, we're ready to take on those next generation. We haven't lost, the knowledge transfer hasn't been lost yet. So if we ramp up when we can, and I know on the reactor side, our university and laboratory programs around the country are putting out young people that are very eager to get into small modular and advanced reactors as a way to really advance their interests in science and technology and do something to improve the planet through cleaner energy technologies. So I think we've got a young next generation of willing employees, both in the fuel cycle but also in reactor development.
Okay, and I want to hear from the rest of the panelists. I only have so much time, so this is an area and issue that is important for, I think, for all of us to understand and make sure we're investing in our workforce as well as we move forward. But there's one thing I want to touch on, and it goes back to my concerns about the nuclear waste. And this is for the panel members. How do or how should advanced nuclear reactor technologies compare to current in-use technology when it comes to the production of nuclear waste? Can you address that, and can we talk a little bit about that, the difference between and how we would address the nuclear waste situation we're in?
Senator,
Go ahead, Clay.
oh, thank you, Chris. Senator, my name's Clay Sell with X Energy, and our waste profile is a material improvement over the light water waste situation in 4 chief respects. Number one, we're a much more efficient user of the uranium, and so from an efficiency standpoint, we produce less waste per megawatt day generated. Number two, our fuel form is a ceramic encased material, and it is a tremendous fuel form, but it is an even better waste form. And so when you think about this waste being stored in a geologic repository, you don't have to consider the kinds of degradation that you face with metal-clad fuels. The third thing is we never have to cool this waste in water. It's just air cooled. And our plant has the ability to store all of the waste that we will produce in the 60-year life of the plant on site. So we're confident that with your legislation and other similar efforts that a consent-based system will lead to a nuclear waste solution, a geologic repository at some point in the next 60 years. But we have got the issue covered in a safe, responsible way that will be fully appreciated by our stakeholders. And we do not anticipate that as a significant issue holding up the advanced reactors. Thank you.
Thank you. Thank you. And I know my time is up. I will submit the rest of my questions for the record. Thank you so much.
I think next we have Senator, is it Hickenlooper? Senator Hickenlooper.
Great. Thank you all for your excellent testimony. And I want to kind of take up where Senator Cortez Masto left off. Just to come back to that, one of the great challenges of developing new nuclear energy assets beyond the cost is the fear, and that there is still this residual concern and fear about, is this new facility going to be built in my community, and what are those risks, and can advanced nuclear technologies offer a solution to this? And in that process, how do we address some of those issues of fear?
Yeah, Senator, this is Jeff Lash. From the Tennessee Valley Authority. I think this is a issue that's trending in a very positive direction. Actually, the largest support for the operating fleet of nuclear reactors around the plants comes from the local communities and governments where those facilities exist and serve, because they have the deepest understanding of the technology. The second comment I'd make is that there is a growing sense, I believe, across the country and around the world, and certainly reflected in this dialogue today, that confronting the issue of climate change and greenhouse gas reduction will require all the tools in the toolbox, nuclear prime among them, and the technology is one of the safest ways to address what is a significant issue. I see that particularly in the younger generations and in the professional workforce that we're growing and engaging in this today. So in direct answer to your question, I think recognition that nuclear is one of the central ways we can cost effectively, reliably, resiliently reduce greenhouse gas emissions and create an economic development for the country at a policy level. And then continued communication that the existing fleet of reactors we operate in this country are some of the safest generating facilities on the planet, and the U.S. nuclear program is the strongest nuclear program in the world.
Great.
If I could add, Senator Hickenlooper, I'll just agree with Mr. Sell that these advanced nuclear plants like X-Energy and TerraPower's offer a significant reduction in waste volume. That was one of TerraPower's goals at the start of our company. And that's really been enabled through advanced computer modeling and advanced materials. We have less waste at the end of the day. We also have much lower accident frequency. So as we go to the public, which we will inevitably do as we license these plants, there'll be public meetings as we go through this 7-year project. We'll be talking to communities about the waste reduction, about the safety improvements. And one other important thing, some of our messengers will be young people. There's many young people entering nuclear energy. We have young PhDs at TerraPower who've just committed their careers to nuclear energy because they want to fight climate change with nuclear energy. So we have technology improvements, and we also have some great new voices that I think are going to help address these concerns.
Well, I couldn't agree more, and I do appreciate. I'm not sure which one of you mentioned the Colorado School of Mines, but I know a couple of the kids out there that are really engaged in studying the future of nuclear power. But the fear does lead us into my one last question. Time always goes by so quickly on these. I thought I'd ask Ms. Roman, you highlight the dominance of Russia and China in the new build reactor market. And how can we take advantage of the increasing export opportunities for nuclear energy and in a real way, I think, push back on, both China and Russia trying to market autocratic government as being the better way around the world. I think this is an opportunity where we can really push back on that.
Yeah, I completely agree. Thank you. First, to your earlier statement about fear and consent-based siting, I've been doing licensing of new nuclear facilities for 17 years, and I can tell you that it's really hard to build any facility in a state and local community that don't want it. And so engagement and making sure you're building it where people want it and that they support it and that everybody is brought to the table to be informed in that discussion is critical to deploying successful projects. Turning to how the U.S. can become competitive overseas, other countries want a U.S. option. They don't have one. I was recently looking at a map of Africa that kind of laid out every country that is looking at deploying nuclear and what their plans are for doing that and who they're talking to. Every single country has either an agreement for nuclear cooperation in place with Russia or with China or both. None of them have any in place with the United States. Same with I was on a presentation where people from Southeast Asia, from Indonesia and Vietnam, were talking about the considerations that they have when they're looking at what technologies they're going to select. And they said, Russia and China are already coming and talking to us, and you guys aren't. And so it's the industry going out, but the industry can't do it by themselves. They can't, TerraPower and X-Energy can't go to a foreign country by itself and say, oh, can you build my reactor? It needs to be in cooperation and coordination with the U.S. government and creating this real genuine kind of Team USA, using U.S. innovators and teaming them with the other tools that the U.S. government has in its arsenal to go and become competitive.
Yeah, we agree. And thank you all. I'm out of time, but I will submit my other questions so they will be of the record. Thank you so much.
Thank you, Senator. I'm going to take the privilege, if I can, to ask the question before I go to Senator Daines because I had to step out for a minute. Mr. Lash, you and I had a good conversation. I really enjoyed it very much, and I was just fascinated by the mix, your portfolio mix for TVA. But also we know that nuclear is emissions-free and plants have baseload attributes and proven track records of complementing variable energies like renewables. I think you all do it all. But without new construction, the preservation of the existing nuclear fleet in the U.S., achieving sustainable energy system would be more challenging and expensive as more renewables come online. Every year in the U.S., nuclear-generated electricity prevents more than 506 million metric tons of carbon dioxide from entering our atmosphere. So if we're serious about using all of the above and doing it right and reducing our emissions, what action should Congress take to ensure that additional nuclear power plants do not suffer premature shutdowns? And you can give me the age of your fleet, how you've been able to maintain and operate at the capacity you have.
Yeah. Thank you, Senator. I appreciate the question. I believe that incorporation of renewables is important. We're building 1,000 megawatts of solar a year, but nuclear makes that possible. That diverse fuel supply, that reliable resource, that high amount of carbon-free energy backstands the renewables that we're adding. Your question about the existing fleet, we have the best performing nuclear fleet in the country or in the world, and these plants are at the peak of their performance over the 50-year life of the industry.
What's the age of your plants, the average age of your nuclear?
Our plants are on average about 40 years old. We've extended the life.
How much life do you have left in them?
I believe these plants can operate to 100 years.
Unbelievable.
We are extending the lives currently from 40 to 60. We will move 60 to 80, and I believe ultimately we'll be able to extend past that. We can do that because we recognize the full value of these plants. One of the issues the fleet is facing.
Let me ask you, I hate to interrupt you, but why is the U.S. fleet then? Why are we decreasing? Why are we taking them offline?
Yeah, because in my view, in the organized markets, we don't recognize the full value that a nuclear plant brings. We have short-term focused energy markets and a very short-term 3-year focused capacity markets that doesn't recognize that nuclear plants can operate for decades at 98% reliability. As was mentioned earlier, they have a captive and secure.
You're saying the power generating companies themselves today, as we have them, different companies I have in my state, my area, and everybody, but they're just not basically utilizing fully their nuclear fleet, or?
That's correct. The markets don't recognize the full value. In order to correct that in the organized market, it's going to take action.
Because all we hear about is, well, as the fossil plants decrease, then we have to come on with renewables. Well, we know renewables don't have storage, so they're not base load. But then the only base load I have ever known to be totally base load was nuclear and coal. Both fuels are right there. Now gas has replaced an awful lot of the coal fleets, and it seems like it's been more competitive and cost-wise against nuclear, so it's replacing nuclear and coal. Gas is. And that's what we're seeing as the national market.
Gas is certainly an important resource, and I agree it is displacing coal. We should be aware, though, that gas, although it's valuable and it's important bridge fuel, it still emits carbon dioxide as an effluent. Nuclear does not. Nuclear adds tremendous economic impact to the communities where those exist. The nuclear unit, on average, probably produces about $1 billion a year.
And the cost of your nuclear, you're selling your nuclear power at what price?
Our nuclear power is the second lowest cost resource on the system. Our hydroelectric is the lowest. Nuclear is the second.
Lower than gas and lower than renewables?
It is. Gas has approached nuclear power prices for us, but not surpassed them. And
Wind and solar?
Both higher than nuclear
I'll be
power
darned.
costs.
Mr. Sell, you have anything on this since you're right in the throng of things?
No, it's a great question that I know the Congress and the states have struggled with. Fundamentally,
We never hear, we don't talk, you understand, all of us here, we don't hear about nuclear. We don't talk about nuclear, and it's been around. We've been running our whole military for, 50-plus years?
Yeah.
But yet we don't even talk about it. It's all we're talking about. And I like renewables. We have renewables in my state. Every state has renewables. But nuclear really does the job, 24/7.
The issue has become in the United States, as we have deregulated the markets and appropriately deregulated them, we have a market design failure in each of the individual states that regulate their
Talking about
electric
merchants,
market.
right? Merchant plants?
Well, it's not just merchant plants. It's a market design that does not value the number one attribute that nuclear power gives, which is 24/7 baseload emissions-free generation. That has a tremendous value, which nuclear operators are not compensated for in the marketplace. And as a result, you've seen good operating plants producing power at very low costs shut down, not in the TVA region, but in the Midwest region, when they were in a perfect condition to continue to operate. And it's really an issue that the Congress, I hope, can work with the states to resolve.
Thank you. My time's up. Senator Daines.
Chairman Manchin, I appreciate your your curiosity on nuclear. I think you made some really great points, and this is a nuclear option both sides might agree on, actually. Sorry. Well, speaking of nuclear, currently Montana does not have any nuclear generation sites. However, our Montana State Legislature, which is in session as we speak, they're working on a few bills that would make it easier for Montana to build a nuclear energy site and to study replacing some old coal-fired boilers with new advanced nuclear reactors. And bringing nuclear energy to Montana would help create more high-paying jobs, as we know. It further diversify and balance our energy portfolio. And with Montana losing important baseload power, as the chairman just talked about, the importance of baseload and affordable, reliable power, we're losing the power, we're losing high power, these high-paying jobs, and as we're adding new, clean, carbon-free energy, like nuclear, could help keep Montana power for decades and help sustain rural communities and jobs that depend on. Ms. Roma, there have been very few new nuclear energy projects built in recent decades, and many of our laws and regulations are very outdated. What state and federal hurdles, like the ones in Montana, should we re-examine to help spur more nuclear power production?
There's a whole host of things to consider. One, for states, it depends on what the state's laws are. Some states have laws in place that outright ban nuclear, and so those states either won't build nuclear or need to revisit those laws. Other states have in place renewable energy portfolios that recognize the carbon-free benefits that renewable energy brings. Some expand the definition of power generation that can fit into that window to include nuclear, others do not. I suspect that as states actually look at how they're going to decarbonize their grid and have a diverse energy portfolio, because you have to realize that even if you have tons of great wind in your state, you don't want to get 100% of your power from solely wind. That's putting all your eggs in one basket and is a pretty dangerous strategy for power generation sources. We need to focus on diverse energy portfolios. So keeping in mind, how do you get that diversity while still meeting your climate goals is probably, and then how do you kind of work down from there is probably a pretty strong objective. From the federal level, there's a whole host of things to be done. I think for advanced reactors, really continuing to support the demonstration projects with TerraPower and with X Energy, and then ADRP is also supporting a number of other advanced reactor companies. I think the most important thing to remember is people, in the United States, we can build a demonstration facility that can also serve as the first commercialized facility. It makes it a lot easier to sell something to other states and across to other countries if we have a demonstrated technology so that people know what they're buying, know what the costs are associated with it, and know what the benefits are. So doing things to support R&D, doing things to support the advanced reactor companies, support innovation, and then any kind of incentives to kind of help take the sting off of particularly employing first-of-a-kind type facilities, such as loan guarantees or cost sharing would be very helpful.
Ms. Roma, thank you. Now, let's assume we solve the nuclear issue here. We start building plants. Got another question, though. It's going to relate to what do we do about the uranium supply? Because we import 90% of our uranium from places like Russia, Kazakhstan, and Uzbekistan. This is despite the fact we've got ample reserves of recoverable deposits throughout the western United States and even in my home state of Montana. In fact, back in the 80s, the U.S. was a leading global producer of uranium and produced almost all the fuel that we needed to power a nuclear fleet, but now our production capabilities are at risk, and we've ceded global leadership to foreign countries. This has caused the U.S. Commerce Department, in fact, in 2019, to determine that uranium imports threaten the national security of the United States. Mr. Melby, uranium can be found with other critical minerals. How can we better coordinate domestic mining to increase both uranium as well as other critical mineral production?
Well, Senator Daines, you're exactly right. Many rare earth elements and minerals, they occur geologically with radionuclides like uranium. So the uranium industry actually possesses the facilities, expertise to actually handle and process these rare earth minerals alongside of uranium operations. In fact, the licensed facility, uranium facility in Utah is doing just that and being part of the rare earth element story and trying to reduce our reliance on those elements, those critical minerals from trying to pull that away from China and Russia. So,
And when we think about guys being global stewards of the environment, we have some of the most stringent mining environmental laws in the world. We should be mining more here in the U.S. instead of depending on foreign countries that have less stringent standards. Mr. Melby, could you briefly describe how 21st century mining practices are beneficial to the environment, for jobs, and our national security?
well, Senator, you know very well in your state with such a mining tradition, the 21st century mining companies today, have not only embraced the highest standards of health, safety, and environment, we're setting the bar for around the world. And so if we push mineral production offshore to other countries, we can't guarantee that those are going to be mined as responsibly as they are here. I also know that the investment community through ESG practices are continually measuring us on our attention to our local communities, the health of our workers, our social responsibility in the places where we operate. So I think today we're a global standard for responsible mining in the United States, and we should do more of it right here.
Thanks, Mr. Melby.
Thank you very much, Senator Daines. Senator King.
Listening to this discussion, I came late. I was in another hearing, but the problem I've always understood with nuclear power is it's prohibitively expensive to build. Plants that are 40 years old that are fully amortized can compete with other forms, but a new plant, the figures I remember, and I may be somewhat out of date, about $5 million a megawatt for a new nuclear plant, $500,000 a megawatt for a gas plant, about 1.5 million for a wind project. Nuclear power just isn't remotely competitive economically in terms of new plants. Now, the key, it seems to me, is innovation and development of these new alternatives that can bring that cost down. But I don't see how we can be having this discussion, at least about new conventional nuclear plants, because the cost just isn't even in the ballpark. Am I wrong, Mr. Lynch? What's the cost per megawatt of a new nuclear power plant today in the United States?
Well, Senator, the initial capital cost of new nuclear power is certainly higher, that initial capital investment, than a number of other generating sources.
It's not only higher, it's massively higher.
But
it's prohibitively higher.
But taken over the lifetime of the facility, which extends 40, 50, 60 years, and levelizing that cost of energy, it's quite competitive. If we focus on nuclear power with a 3-year time horizon, like many organized markets do, it can't compete. But if you think of the total value of a nuclear plant and its lifetime, much like any other capital-intensive asset, and levelize that cost, it's actually quite competitive. New nuclear designs are lower capital costs per kilowatt installed, shorter construction durations, and smaller sizes to reduce that initial capital investment. And like the existing nuclear plants, when thought of over their lifetime, are quite competitive.
I appreciate that, and that's why I emphasize that I think demonstration projects, R&D, additional support for the new technologies that can bring that cost down, and also the construction period. A question about rate making. Your point is well taken of the lengthy life cycle of 40 or 50 years. Do our current regulatory structures allow for that kind of spread out of the cost? Because the problem is the bankers or the people, the finance, they want their money back, maybe not in 3 years, but they want it back in sooner than 40 years. So is there a way to levelize the cost in terms of impact on the ratepayers?
Yes, we have various regulatory structures in the U.S., which is part of the complication. For integrated investor-owned utilities, Southern Company, for example, that's building the Vogtle site, the regulators providing oversight can work with them to do exactly that. For the Tennessee Valley Authority, where we're public power, we continue to operate our plants quite successfully and could build new nuclear because, once again, we have the regulatory construct to amortize that over the life of the plant and levelize that cost and make it competitive. When you move to organized markets who, by their design, have short-term focus, day ahead week-ahead energy markets, 3-year capacity markets, that regulatory structure makes it very difficult to build any investment that takes a high upfront capital cost but delivers significant benefits in the long term. And I think if we're going to preserve
I
our
understand
system,
that. I've done business in those markets, and the problem is they essentially discriminate against any capital-intensive energy form. They make natural gas pretty much the only alternative.
yes, and to Senator Manchin's earlier question, that's why the existing nuclear fleet struggles in those markets, and it's an issue that we really need to correct to preserve that fleet.
Thank you very much. Thank you, Mr. Chairman.
Thank you very much, Senator King. Senator Lankford.
Thank you. Thanks, y'all, for the testimony. It's extremely important to be able to have this dialogue. Let me follow up with just with a basic question on this that I think we've talked about a little bit on the edge, but it's been interesting to do some reading on it. Mr. Elias, is nuclear power determined to be base power, or is it flexible power? Is it intermittent power, or is it determined to be consistent?
Senator, I think you could characterize nuclear power as either baseload or flexible, depending on the plant design and its operating regimen. We have historically thought about nuclear plants as baseloaded, and that's the way we tend to run them in this system. But the technology can fill any one of those roles if designed and located properly.
So why would it be flexible? Why wouldn't it be base? What would be the design and the reason to be able to use it as flexible?
I thought Mr. Levesque pointed out a good example where using thermal salt storage to store the power, it can operate as a base load, or you can use that storage capability as a peaking resource, as a good example of the flexibility in nuclear technology.
Okay.
That's correct, Senator, and that's one of the design goals of Natrium. And, you know, when we talk about the economics of nuclear energy, better economics involve lower costs that's enabled by new technology. But better economics for utilities is also related to you know, the rate at which the power can be sold. In a plant like Natrium, being able to flex is going to be able to participate in capacity markets where the electricity will be at a higher cost. So, you know, again, in the past, nuclear has been base load, and new plants like Natrium allow nuclear to participate in, you know, entirely new and more economically attractive markets.
Mr. Levesque, you talked a lot about having the power that is more of a smaller modular unit and not trying to create as large. Tell me the advantage of that and how many facilities would have to be built to be able to make a difference on our power source across the country.
So to be clear, Senator, if we think about 2050, we envision many small and, this is TerraPower, we envision many small and large nuclear plants. You know, today, most nuclear plants are gigawatt scale. And yes, we're talking about building smaller plants on the order of 300 megawatts per station now. That's what customers are looking for as they retire coal units, as we work nuclear into an established grid in countries like the US and Europe where there's developed grids. But certainly as we prove out these first units at 300 megawatts, we anticipate growing the Natrium output you know, back up to gigawatt scale. And again, if we think about 2050, we imagine many nuclear plants around the world, you know, new 300 megawatt units and also new gigawatt scale units as well, providing both electricity and process heat.
So, Levesque, let me ask you, when you say by many, give me a number. How many are you talking about? To be able to cover the United States by 2050, how many facilities would have to be built that are nuclear to be able to cover our energy needs?
Yeah, it would be scores of plants. It all depends on you
More
know,
than 10?
Certainly.
More than 100?
Certainly scores of plants. And yeah, the opportunity for these advanced reactors is in the hundreds. I mean,
so are we talking 1,000? Are we talking 1,000 that would have to be built by then?
Certainly hundreds between now and 2050. And that's why companies like TerraPower and X Energy are bringing so much private investment, because we plan to sell and deliver hundreds of plants. That's how we'll get the return on investment.
To get to a zero emissions by 2050, does anyone have a good idea how many facilities we would have to build by 2050? Because we've talked a lot about wind power and solar power and how many acres that would cover. Actually, how many entire states that would have to cover to be able to do that. How many nuclear facilities would we have to build to be able to get to that point by 2050? Does anyone have a good number for that?
I do not have a good number, but when you're talking about zero emission, that's increasing the entirety, eliminating the entire coal fleet, eliminating the entire natural gas fleet, and eliminating the industrial, or converting the industrial heat use, which is 90+% fossil fuel, all to non-emitting baseload technologies. And that's going to require hundreds of plants, hundreds of gigawatts of plants over the next 50 years, far greater than, we operate basically 100 gigawatts of plants now in the United States that were built between 1960 and 1995. We're talking about doing a multiple of that between now and 2050 in order to get close to achieving the kinds of decarbonization goals that you've outlined in your question.
And each one would cost about how much each?
The X-Energy plant, we're going to be competitive with the price of natural gas. So we have a price at less than $50 per megawatt hour on a go-forward basis.
Okay. Thank you, Mr. Chairman. Thank you.
Thank you. Senator Cassidy. Senator Cassidy, are you available? We may have had to go to vote because we're in the middle of a series of votes. So while we're waiting for the chairman to come back, and we have 4 votes going on, and the chairman is going to do the end of the first vote and the beginning of the second vote. I voted already in the first vote, so I'm going to go with additional questions, and we'll then wait the chairman. Ms. Roma, the world is looking to expand the use of nuclear energy to meet our environmental as well as energy goals. Why is the United States leadership in the nuclear energy sector critically important? And can you also talk about what the consequences would be of losing nuclear deals to, say, Russia and China?
Sure. It's critically important for the United States to be a global leader because that's where we've been and we've had huge dividends. It's prevented the spread of nuclear weapons. It's ensured that U.S. safety standards that come out of the U.S. Nuclear Regulatory Commission are widely adopted around the world as setting the gold standard for how you should regulate nuclear power plants to make sure they're run safely. It gives the United States a voice on nuclear safety and security purposes, and allows us to strengthen and further develop relationships with countries that are building nuclear power plants that aren't just necessarily longtime U.S. allies, but allies that we're trying to establish further relationships with. And that happened more recently with the UAE, where they didn't build a U.S. reactor design, but a number of U.S. companies helped support standing up that program. And that significantly influenced the safety standards, the implementation, the nuclear safety culture. I think that's something that we don't talk about very often when we talk about how important it is in running a nuclear power plant. But that's the idea that anybody within an organization can raise a safety issue, no matter what tribe you belong to, no matter what position you have within the plant. And in some of the places where we're building nuclear power plants, that entire concept is a foreign concept to them. And so kind of embedding that at the beginning of a program, make sure that when countries that are new to nuclear and developing nuclear, that they do it safely and in a way that makes sense. From a geopolitical standpoint, when we look at Russia and China, we have to look at not what are they just doing with nuclear, but what are they doing generally. Russia historically has treated its work in foreign countries as a geostrategic objective where it can go and exert its influence. And by building, owning, operate, and controlling the major source of someone's power supply. I mean, one of the things that we talked about a little bit here when we think about nuclear is, yes, it's expensive, but it's also immense. It's huge amounts of electricity for plants that can operate for 100 years. And so when you look at building that much electricity in a country, if you have Russia who built, owned, operated it, and can shut it off, they now have a leverage over a foreign country that they didn't have before. That's probably a more aggressive tactic, but it also allows them to establish a further deeper relationship with that country as well. For China, they see an economic opportunity, but one of the things that I think is a concern is when China also builds, owns, and operates a nuclear power plant in a foreign country, that it's financing, the Egyptian reactors that Russia is building, it's financing for a 30-year finance period for a 2% annual rate of return to the tune of like, I don't know, $20 billion. When China offers the same thing and all of a sudden a country in Africa can't make due on its payment, China has the ability to kind of foreclose on that and then exert its economic interests further in the country by taking over their power supply. The United States doesn't do that. That's not how we operate. And we need to be able to offer other countries an option that isn't as predatory and that is more benign, while at the same time also hugely economically beneficial to the United States.
Thanks so very much. Senator Hoeven.
Thank you, Mr. Chairman. I appreciate it. My first question is for Mr. Melby, and that is, in your testimony, you mentioned that the national defense requirements for U.S. uranium, including nuclear deterrence, and in North Dakota, that's certainly the mission of the Minot Air Force Base. We have both the B-52s with the nuclear capacity as well as the ICBMs. And so my first question is, we need an industrial base, obviously, to support military uranium requirements, but are the defense needs by themselves enough to create enough demand to sustain the required industrial base?
Actually, the easy answer is no. I think the combination of commercial nuclear power and defense needs can be complementary to each other. We've seen our defense needs met by stockpiles of uranium and fissile materials that were built up all the way back to the 1950s and 60s. And so we haven't worried much about availability of future supplies. But we do know that these are finite and diminishing inventories, and those within the Defense Department that are looking out at our not only existing fleet of aircraft carriers and submarines, but new future deployments are concerned that we lose that domestic ability to produce not only uranium, but conversion and enriched uranium in support of our defense needs. So fortunately, with a robust commercial nuclear fuel markets at home and abroad, this doesn't have to be solely on the back of our defense budgets, but can come out of the commercial nuclear fuel cycle.
Do we have enough industrial demand, commercial demand, to maintain a source here, or are we reliant on other countries?
Well, we have the demand. If you look at nuclear generation globally, I think we're back to pre-Fukushima levels of nuclear generation and hence uranium demand. So that's certainly not a problem. It's just the period of low prices, which we're now only beginning to come out of. We need to maintain that domestic capability. We're coming awfully close to losing it. But the infrastructure, the natural resources, and the people are still in place and can ramp up quite quickly. I think the uranium reserve, if DOE can stand that up quickly and get it going this year, it was a bipartisan support of the budget for this year, and we get it funded in future years. That's an excellent stimulus to get this industry back going, not only for commercial nuclear power, but defense needs as well.
Mr. Levesque, I would kind of ask you the same questions. Where are we in terms of the supply and our ability to produce the uranium that we need, and do you have recommendations on steps that should be taken regarding it?
Yes, certainly, Senator. TerraPower's design, Natrium, will require high-assay, low-enriched uranium, which is the same uranium that we're hearing about from mines in states like Wyoming. But I wanted to point out that these new technologies, like Mr. Sell was mentioning as well, require a higher level of enrichment. So not only do we need to reinvigorate things like the mining infrastructure, but we do not have enrichment capability in the U.S. today to produce HALEU, high-assay, low-enriched uranium. So TerraPower and X-Energy are working with the Department of Energy to identify a source of HALEU for our demo units. But again, we plan to sell many, hundreds of these X-Energy and TerraPower reactors. And for that, we're going to need not just uranium supply, but we're going to need enrichment capability, U.S. enrichment capability for high-assay, low-enriched uranium. Our partner, Centrus Energy, has a small pilot project going on today to demonstrate that HALEU production, but we definitely need to ramp up that capability in the U.S. if we're going to be ready to provide hundreds of plants in the U.S. and worldwide that are fueled by high assay, low enriched uranium.
Thank you. Ms. Romley, your thoughts as well in the time I have remaining here.
So it's critically important when we think about our energy need that we also think about energy security and independence. Anytime you build a power source, you need to be able to make sure you have your fuel nearby. The entire front end of the fuel cycle has been degraded when we saw the decline in the domestic nuclear power industry in the United States, the mining industry, the milling industry, the conversion industry, and the fuel fabrication. We need to be able to have these capabilities. The great news is it's not a supply problem. We have immense amounts of uranium in the United States, and we need to make sure we keep these capabilities on hand and fresh. And sometimes, I think as we saw most recently with the N95 mass shortage, sometimes you don't know you need something until you can't get it. And we just don't need to be in that situation with uranium.
Thank you, Ms. Roma. Thanks to all three of you. And thank you, Mr. Chairman.
Thank you, Senator Hoeven. Senator Murkowski.
Got to get that right. Thank you, Mr. Chairman. Thank you for this hearing. So appreciate the opportunity to focus again on the benefits of nuclear and particularly advanced nuclear reactors. I think we were able to accomplish some good things in this committee last year, and we want to be able to continue to build on those. I want to focus my questions this morning on some of the regulatory matters related to microgrids. So I don't know, perhaps this is a question best asked for Ms. Roma. We have several microreactors that are in pre-application review with the NRC. One company, Oklo, has an application accepted for review under the combined license approach. The issue is the regulatory structure equates an operating permit with a specific site there. So what should we do with this? Should Congress act to create new exemptions for microreactors so that a single design can be permitted for multiple sites? How can we, again, allow for an approach that will ensure greater commercialization opportunities for microreactors? And I pose that to Ms. Roma, but if there are others that wish to respond to that, I'd appreciate.
I can start off and then maybe others can hop in. So the NRC does have a design certification process, but the NRC kind of regulations that they stood up were for large-scale light water reactors, and they envisioned a very slow and long process where a company applied for a design certification. Once the NRC reviewed and issued the design certification, which can be a 5 or 6 year process, then a company could apply for a site-specific combined construction and operating license application. It could also apply for an early site permit where the NRC would do early environmental review of a site. And then it could apply for the COL and then get the COL. That whole process combined, which is probably what the NRC's preference would be for anybody doing licensing, can take decades,
right,
and is cost prohibitive and doesn't make any sense, particularly for designs like microreactors, which have very, very small footprints, both from a public safety standpoint and from an environmental standpoint. And the NRC has been really looking at its regulations to figure out how can we right size these for these types of facilities, but they're bringing their large light water reactor mindset, which is really a round peg in a square hole. And so what Congress can do is kind of any legislation to support the streamlining or even help check certain boxes so that the NRC can do a more efficient, not a less robust, a more efficient review commensurate with the size and impact of these facilities. That would be very, very helpful.
Well, I appreciate that. I've tried to outline the potential that we would have in a place like Alaska, where I think we have some interesting applications for microreactors and what we might be able to deploy. But when you look at the structure within the Regulatory Commission, it's just not set up to help facilitate deployment in a state like Alaska, where you've got some pretty remote communities, some pretty remote sites that would benefit from exactly this type. So you're suggesting we need legislation. NRC says that they're dealing with what they're going to deal with. Did one of you, Mr. Sell, nice to see you.
Senator Murkowski, there is something interesting going on that I think is relevant. And that, as you may know, the Department of Defense has a program to design micro mobile reactors for forward operating bases. Our company, X Energy, is one of the companies involved in that design effort. That reactor will be deployed on a prototype basis by 2024. And although it will be licensed by the Department of Energy, the NRC regulators are embedded into the program. And so there is an opportunity for the NRC to observe, to learn, and to take lessons out of that and apply those to the commercial applications like Oklo and others. So it's a rapid technology development program, and the licensing process to go along with that is having to evolve to go with it, to move at the appropriate level of speed. And I think real lessons will come out of that effort.
It's my observation is that we're at that point where we're building out the prototypes. We know what it is that we need to do. The things that's slowing us down is the regulator, who hasn't caught up to the fact that this is not, your father's Oldsmobile in the sense of what we have been building in this country in terms of nuclear facilities for so many decades.
I think that's true. I will acknowledge that the last number of years at the NRC and now with Chairman Hansen, there is a strong commitment at the leadership level to be responsive to the laws that this committee originated and passed and reform the process. And they want to do the right thing. But, sometimes it's change management in a large organization is challenging, and we're going to continue.
I would agree. I would agree, Senator. The leadership has been very progressive, and I think legislation that empowers the NRC to consider new approaches towards regulation, that's really helpful. And finally, I'll add that, I've worked around the world in nuclear energy and been asked many times in other countries, what does the NRC think? The NRC is the worldwide standard for nuclear safety. And if we think about a Team USA approach, if we have advanced reactors that are licensed by the NRC, the U.S. is going to be so competitive worldwide, offering these reactors as options to Russian or Chinese technology.
Thank you. Mr. Chairman, thank you. I have additional questions that I'm probably going to submit for the record, where, as you know, we're bouncing in between votes, but this is such an important hearing, and I really appreciate that.
Thank you, Senator Murkowski. Senator Cassidy.
Hey, thank you all. And again, it's a great hearing. I too have been bouncing between committee hearings and votes, so I apologize if there's redundancy into what I ask. Mr. Wells and Levesque, what will be the cost per megawatt hour? Both, first, how much is it going to cost to build one of these? What is their capacity? And after kind of you don't want to be the first one, but after you kind of got the flow down and you've built 4 or 5, what can we expect the cost to be then? And how much will it cost to operate per megawatt hour compared to other forms of energy?
Okay, Senator, the first units, these demonstration units that TerraPower and X Energy are working on, they will cost several $billion each because they have all of those first-of-a-kind costs that Mr. Sell was mentioning, that the first-time licensing, the first-time design, and also, frankly, the U.S. supply chain and the U.S. Infrastructure is out of practice. So those first demonstration plants will cost somewhat more because of those first-of-a-kind and learning curve things, and that's what makes it ideal for us to have the ARDP, which is public and private funding, kind of, overcoming this speed bump to get us into the next technology. But after the demonstration, we see plants that are going to be, because of the technology differences, again, because of things like lower pressure, we're going to have plants that are totally competitive with natural gas. They're going to be safer. And again, in the case of Natrium, it's going to be able to flex its power and participate in electricity markets that are more lucrative than what nuclear plants can.
But Mr. Levesque, just to put a point on it, could you have, okay, you've built your first 5. So then do you have a projected cost of what it would cost then? Because I think, Southern companies, and Mr. Layash was involved with CB&I, they attempted to do something for Southern companies and initially had to rebuild the whole training of the workforce, but it still ended up being incredibly expensive. And it never got over that initial bump. By the way, I'm supportive of it. I want this to happen. So I'm just trying to figure out what the landscape looks like.
Yes, Senator, the landscape is this, the U.S. Is rusty. Russia and China are building many units.
I get that,
yeah.
but
Yeah.
do you have a projected cost after you've done your first 3 or 4 and you've kind of worked out the kinks?
Plants that are on this 300 megawatt size should certainly cost, less than $1 billion. They'll be competitive. I also want to point out, by going to some of these new plants, the number of U.S. jobs and the invigoration of the supply chain should increase. Light water reactors today, you have to go to Japan to get super heavy forgings for the pressurized water reactors.
Let me just ask, because I only have a couple minutes left. Mr. Lash, I apologize if I'm mispronouncing your name, but I was able, when I was listening earlier, you seemed to be talking about some challenges, and so I didn't hear the whole conversation. But to what degree? But you were talking about why are we decommissioning some of our existing nuclear? And to what degree do production tax credits and other incentives to allow renewable energies to sell below market, to actually pay people to take their energy, to what degree has that played into the demise of the decommissioning of some of these plants?
Yeah, Senator, I think it plays significantly into it. As Mr. Levesque was saying, these plants are high capital cost, but when you levelize the cost over the life of the facility, 20, 30, 40, 50 years, they produce quite competitive levelized cost of power, but they deliver more than that. They deliver reliability, fuel diversity, fuel security, huge amounts of zero carbon electricity. These don't have...
I'm totally getting that, Mr. Lash, again, but just back to the point, because we're going to be making decisions regarding tax breaks for renewables, some of which are quite mature, but nonetheless, advocates are still advocating for continuation of the tax breaks. So to what degree are these tax breaks playing a role in the decommissioning of a nuclear power plant in Illinois, for example?
Directly, because these attributes of nuclear power aren't rewarded by the market, and wind and solar have tax credits, production tax credits or investment tax credits, they artificially depress the price of that energy below the nuclear plant and contribute directly, I should say, to a non-cost competitive position of those plants. Not because
I once heard somebody say that paradoxically, renewables in the current environment, by forcing the construction of baseload facilities, but simultaneously forcing the decommissioning of nuclear power plants, which would be the natural baseload, are actually paradoxically increasing global greenhouse gas emissions. Maybe too strong of a statement, but is there some rationale to that?
There is. The intermittent renewables, with the depressed prices due to production tax credits and investment tax credits, are forcing high-energy baseload units into a non-competitive position. The retirement of those baseload units makes the addition of renewables not possible, or at least not possible without significant adverse effects on reliability. These things have to move together in balance to have a system that is both economic and reliable in the long term.
One more question, because I'm over time, Mr. Levesque. Mr. Lash points out that, yes, initially your cost is high, but if you levelize it over 60 years, I think there's a nuclear power plant in Louisiana that may go for at least 60 years. What is the actual cost? Once you've done your construction cost, what is going to be the cost of operating and maintaining one of these plants? Because it does sound like your initial construction plant is still going to be more expensive than a natural gas. But what was just implied in that is that your operation and maintenance could be less than a other form of energy.
Yes, Senator, certainly cheaper than natural gas on that levelized cost. And, with automation and technologies, the required staffing at the plant to operate the plant should be much lower. And again, if we secure these U.S. Fuel and enrichment sources, that'll give us greater control over, the life cycle fuel cost.
Gotcha. Okay, I yield back. Thank you.
Thank you very much. Appreciate it. Mr. Sell, I appreciate your support for the establishment of a uranium reserve. You talked about that. Your written testimony highlighted the need for a specific type of uranium, a high assay, low enriched uranium. You stated the timelines set in the Energy Act of 2020 are not aggressive enough to meet your needs. I think you stated you need this material by 2024. So will the Department of Energy be able to supply the necessary material to meet your needs? And if not, how are you going to secure the material?
Well, Senator, it's really not the Department of Energy's total responsibility. There is a commercial market for HALEU, and Centrus is a private company, and they have a pilot project that is funded by the Department of Energy to begin the production process. But I'm going to need about 3 tons of high-assay LEU in the 2024 timeframe in order to start the fuel-making process for our first plant at Energy Northwest. And so I think there's going to be there are a number of initiatives that will have to be pursued in order to increase the availability of HALEU for that first plant.
Thank you so much for that answer. Mr. Levesque, is there anything that you would like to add to that?
No, Senator, we have a very similar need with TerraPower's Natrium reactor.
Thank you. Senator Manchin.
I'm so sorry, Senator Barrasso. They're still on the first vote, if you can believe it. I thought it would have wrapped up when I went down. I could have voted twice and come back, but this is the Senate. Welcome to the most deliberate body in the world. If I'm repeating questions, please forgive me and then let me know what you're thinking. I just thank all of you. I really believe we're missing a golden opportunity if we don't get back in action. And I think Mr. Lash and I had, like you said before, we had a good conversation and realizing how strong TVA is, but it's a whole different ballgame, the way it was created, who it is, how it operates. But they do it and do it so well. If it can work in that type of environment, it can work in the market environment too. But I'm understanding from what you all have told me is that starting with FERC, starting with regulatory, basically in Washington, demanding that we have that type of dependable, reliable, and affordable power, which is base load. And, because we've had other things kind of freeze up, we've had other things kind of shut down, stop, and I think Texas is a wake-up call. I'm more concerned also, too, about the security. And I think nuclear can scare the daylights out of some people thinking of the catastrophe. I remember 3 Mile and how this happened. So they're saying, oh boy, if we have a cyber attack, I'm gonna let all of you comment on it. If we have a cyber attack, then we're really in the problem there because they can really melt this thing down and cause catastrophic, okay? So Mr. Sell, if you want to start on that, and then we'll go right down.
Thank you for the opportunity. The X-Energy plant is intrinsically safe. So what does that mean? What it means, Senator Manchin, Chairman Manchin, is that our plant cannot melt down. What happened at 3 Mile Island is physically impossible to happen in an XE100 plant. So is the plant safer? Yes, it's safer. But the more important thing is we do not have to build all of the safety-related systems that a typical light water reactor plant has to make. So we result in a much simpler plant that is more economic to build and more economic to operate. And that is why our plant can be built quicker, can be operated more cheaply, and therefore it's much more attractive from an economic standpoint than traditional large light water reactor plants.
Mr. Melby, do you have any comments on this? This is my last question.
Yeah.
I just need to know how we can make sure that nuclear is allowed to do the job we know it can do. And right now, we're not in that mindset, is what you're telling me. It's aspirational. Everybody wants to stop this, stop that, and let's do everything with renewables and this and that, and I understand. But we know it's not going to carry the load. It will not afford us 24/7, rain or shine. And to be the number one and be a superpower of the world and having the demand for power that we've taken for granted all these years, we've got to continue in that mindset, energy independence. So anything, just quickly a comment from all of you on that.
Well, I'll just reiterate what you said about Texas was a wake-up call for all of us. We have operations down there, so we saw what happened firsthand. And, the resiliency, the 24/7 aspects of nuclear energy, the predictability of fuel cost. Gas is a great way to make electricity when gas is cheap, but we've found out with $18,000 electricity bills, that when the price of gas goes up, it hurts that form of energy. So nuclear can really be the complement in as you've all
Did any
said.
nuclear go down in Texas? Does Texas?
We have 4 units in Texas. One did go down for a day, but was.
Well, I thought the water supply line froze up, is what I understand.
So we were 75% up, but back to 100% after a day.
But if there had been weatherization precautions taken, that should have never gone down.
They're already taking them.
Gotcha. Mr. Lash.
Yes, Senator, I would just stress that the nuclear, non-light water and light water reactors are going to be critical to maintaining reliability, economic development advantage, and hitting our environmental objectives. And in answer to your question, I would suggest 4 things. First, action needs to be taken to preserve the existing nuclear fleet and to address this value that's not recognized by the organized markets that needs to be recognized. If we don't preserve that fleet, we cannot maintain or develop a leadership position in the world on nuclear power.
What do you know about the fleet, sir, because you have a tremendous amount of experience in this operation. What do you know, and any of you all know, about the fleets that have been shut down or those that have been targeted to be shut down? Is there any other reason except market decisions that people are making right now that those should ever be shut down?
No, the primary reason here is market decisions, and it's a short-sighted view of the value of
Gotcha.
the plants, and we must address that.
We will get on that. We can get into that real quick.
The second step I suggest is you're already taking, and that's to recognize the role of nuclear at a policy level in addressing long-term climate change objectives. The third is to support the development and deployment of advanced reactors, light water and non-light water reactors, and I think the ARDP is a step to doing that. I think more is going to be necessary to create this advanced reactor industry for the U.S. and to make it an export for the U.S. around the world. The last is just to make sure that the regulatory and federal agencies that have to support extension of the existing fleet and licensing of new are properly focused and resourced to do just that.
Ms. Roma, do you have any comments you would like to share?
Yeah, actually, Senator, I thought it was great that you started off with your cyber fear for nuclear, because when you look at any critical infrastructure, nuclear power has the most advanced cybersecurity protections, and you can't hack it, right? You can't cause any kind of harm at a nuclear power plant from a cyber attack, which is fantastic and just shows you how robust this technology is. When you look at advanced reactors, most of them
I hope you share that with our federal government and our Department of Defense, because we get hacked every second of every minute of every day.
Yeah, well, and they try to hack nuclear power plants. It just doesn't work. There's just too many layers of defense, and they're not attached to the grid. So any of the security systems aren't attached to the grid, which makes it really, really robust. But from a safety and security standpoint, with advanced reactors, a lot of them they're small, they're buried underground. You could do whole lots of bad things to them, and nothing's going to happen because they're underground, so they're not going to hurt anybody or harm anybody. But I think to your underlying point, right? This is an important discussion, and it needs to be based on facts, not fear. And so we need to have this conversation. The American public needs to be engaged and make decisions that they feel fits what they need, carbon-free, safe power. And we can do that. We just have to keep.
Well, here's what, before I go to Mr., I think I have one, Mr. Livek, if he would have anything. Livek?
Yes, Mr. Chairman, advanced nuclear is going to give you that reliability and resiliency that the current fleet has, to sustain multi-day tropical storms in Florida or the polar vortex in Illinois. Advanced nuclear is going to give you that kind of reliability, but it's also going to give you those safety and cost improvements that Mr. Sell and I have been describing.
Let me just say this, and then we'll go to Senator, to Marshall to finish up our meeting. Just a lack of knowledge, a lack of education to the people. I've always believed, because the life cycles of anything. So coal-fired plants, we knew what their life cycles were, and they start ending the life cycle. Then it was a time to deploy them out and cycle them out. So we think in the same terms. Well, it's not. What you're telling me, that's not the case. If they're properly maintained, they can go on and on and on with some technology changes, I guess is what I'm understanding. So if you're going from a normal plant, probably in TVA or any of you all, when those first came online, maybe you had a 40 or 50-year life to them, but you found out that you can extend those lives very, very safely in this environment. We've got to now find out every nuclear plant that's on the chopping block right now and get to the CEOs of those companies and make them come here and tell us why they're taking offline something that should never have been taken offline, shouldn't even be considered to be taken offline, and why we can't build the rate in to make sure they're able to operate at that level. We can do that. That's our job here for the sake of our country. That's what we're looking for. So you all have been invaluable today. And with that, I want to thank each and every one of you, but I want to turn to my friend, Senator Marshall, for his final round.
Yeah, thank you so much, Chairman. It's great to be here with you all this morning. I was on my path to become a nuclear engineering when medical school interrupted it. So certainly a field that's been near and dear to my heart growing up. Watching Wolf Creek Nuclear Power Plant in Kansas being built, I think was an inspiration for a lot of young men and women to go into engineering and study math a little bit harder. I think my first question probably to be to Ms. Roma. I'm just shocked to see these nuclear plants being retired, in my opinion, prematurely. Everything that we're talking about, what's an economical way to get to lower carbon? Would it say to keep the existing plants operating? What's leading to these being shut down prematurely? Who's making that decision? Who's driving that decision to shut these down ahead of time? Ms. Roma, yeah, go ahead.
Yeah, well, the nuclear power plants are businesses, and they recover rates and get paid for the electricity that they generate, and that's based on the existing market structure we have in the United States that just says how much does it cost to produce electricity over the next few years, and they go with the cheapest, and then they go to the next cheapest and next cheapest until they're done. And so when you look at the price of natural gas, until about the 2008 timeframe, the new nuclear was very competitive, and actually dozens of nuclear power plants were planned because the price of natural gas was higher. Around 2008, the price of natural gas took a sharp dive down, and then we discovered we can probably just leave it down there for a while, which all of a sudden made nuclear not economic anymore. When you look at renewables, they're subsidized. They're intermittent, huge, importantly part of the energy mix, but they're intermittent and they're subsidized. And so nuclear just doesn't fit into the mix anymore. But the largest value that it has besides providing immense amounts of constant power is that it's carbon-free and secure and reliable.
Huh, okay. Is it Lyash? Okay. I guess what I hear her saying is that it's probably a huge capital cost, obviously, to keep these plants to keeping them going. So it's just cheaper to build a new coal plant, or it's cheaper to build a new natural gas plant than it would be to rehab these and keep them going? Is it just economics?
Yeah, I think what was pointed out that the markets aren't structured to reward the value of this is right on target, but I think there's a deeper problem. It stems from a very short-term focus on our energy plan. We're in the market buying whatever the cheapest energy is by our definition today, not recognizing that diversity in the energy supply, in terms of fuel, in terms of technology, in terms of the economy, long-term environmental objectives, is how we really need to plan this energy system. It's the same conversation we had earlier with respect to uranium mining and enrichment, taking the long view and the global view. I think the same view needs to be taken of the energy mix in this country, and if you do that, technologies like nuclear emerge as a critical role to meeting our long-term objectives. And I think the markets need policy, and they need signal, and they need direction in order to establish that kind of balance.
Great. Being a big defender of nuclear engineering for decades, the question always posed for me was the disposal part of it. And as I think about electric cars today, I'm equally concerned about the environmental impact of disposing of their batteries as well. And I'm thinking of these big graveyards of electric batteries. And I know everyone's going to talk about future technology. We're going to reuse it all. Is there anybody that's really seen any good environmental impacts of nuclear waste versus just the equivalent number of batteries we're going to have to throw away to make this worse? If this was happening today, not future, are there any good studies out trying to compare apples and apples?
Senator, spent nuclear fuel is extremely well understood. We can store the lifetime of fuel ever used safely on the nuclear site that utilized that fuel. Alternatively, as a country. We could go to regional storage or monitored storage. Countries around the world have moved safely to geological repositories. The strength of nuclear, even in the face of the spent nuclear fuel, is that we understand it, we contain it, and it has no impact on the environment. Unlike what we're seeing, for example, with transportation, where we drive down the street with our automobile, we emit waste from the tailpipe, we're not sure how much, we're not sure where it goes, we're not sure what it's doing. And so I think the nuclear waste issue is certainly not immaterial, it's significant, but it is not a safety issue, and I think it's an issue we can solve in the long term.
I guess I'm past my time, but I've been told we could take all the nuclear waste in the United States and put it on one football field, and if we just had a place to do that. So thank you so much, and I yield back.
Again, let me thank each and every one of you for taking time and effort to come here, because it's been invaluable. I can tell you, you've helped me a tremendous amount, and I think you helped our committee understand better what we're facing and how we can basically decarbonize without basically killing ourselves, if you will, shooting ourselves in the foot. So I would say this: members will have until close of business tomorrow to submit additional questions for the record. The committee stands adjourned. Thank you.